In 2013, NASA astrobiologist Kevin Peter Hand wrote in an internal memo that Europa represents the most likely place in the solar system to find life beyond Earth. He followed that sentence with another one, which received considerably less attention. He wrote, "We may not be prepared for what we find." Those are not my words. And that qualifier, "may not be prepared," coming from a man who has spent 30 years training for exactly this discovery, should stop you cold. Because preparation, for scientists of Kevin Hand's caliber, doesn't mean emotional readiness. It means scientific framework, protocol, ontological categories. He wasn't saying we might feel overwhelmed. He was saying the universe might hand us something we do not yet have the intellectual architecture to understand. What moves below the ice of Europa? We don't know. But here is the thing that should keep you awake. We have never been more certain that something does. When the Voyager 2 spacecraft swept past Jupiter in 1979, the images it sent back of Europa were, at first glance, almost boring. A smooth, pale sphere, whiter than the moon, featureless. Scientists nicknamed it the billiard ball of the solar system. Against the violent volcanic chaos of Io and the hallucinogenic storm systems of Jupiter itself, Europa seemed almost restful. A quiet place, a place where nothing happened. The surface reflectivity, what astronomers call albedo, was extraordinarily high. Europa was reflecting 67% of all sunlight that struck it. That meant the surface was almost entirely ice. Smooth, unbroken ice. An entire world's ocean, frozen. Nothing threatening about ice. The scientists filed their reports. The images were archived. Europa was cataloged as a frozen moon, interesting but inert, and the solar system moved on. Except it isn't inert. The Galileo spacecraft arrived at the Jovian system in 1995 and began returning data that quietly, methodically dismantled everything we thought we knew. The ice was not uniform. There were regions that had fractured and refrozen in completely different orientations, as if plates of the surface had been free-floating, had actually moved, before being welded back by the cold. Scientists called these regions chaos terrain. The name was not chosen for drama. It was chosen because the word chaos already existed in planetary geology to describe surfaces where the underlying material had liquefied, shifted, and re-solidified. The underlying material of Europa's surface had been liquid. It had been liquid recently. In geological terms, recently can mean millions of years. But Europa's surface has almost no impact craters. In a solar system being constantly peppered with asteroids and comets, a cratered surface is a surface that has been stable long enough to accumulate its scars. Europa has almost no scars. That means the surface is young. In the outer solar system, young can mean 10 million years. It can also mean 10,000. It can mean the ocean beneath it is moving right now. The Galileo magnetometer recorded something extraordinary in 1996. Europa was producing its own localized magnetic field. An induced field, one generated not from a solid iron core the way Earth's is, but from the movement of electrically conductive fluid. The only fluid in the right location and the right quantity to produce that field signature is a global salty ocean lying directly beneath the ice, estimated at between 60 and 150 kilometers deep. For reference, the deepest point in all of Earth's oceans is 11 kilometers. Europa's ocean is, at minimum, 5 times deeper. There is more liquid water on Europa than on all of Earth. Here is where the beauty of this place begins to curdle. The ice shell, depending on what region you examine, and depending on which model you trust, and scientists do not fully agree, is somewhere between 3 kilometers and 30 kilometers thick. 3 kilometers is the thinner estimate. 30 is the safer one. Even at 30 kilometers, that ice is being constantly stressed, cracked, and processed by tidal forces from Jupiter itself. Jupiter is 318 times the mass of Earth. Europa orbits at a distance of 670,900 kilometers, and it orbits in a slightly elliptical path. The difference between Europa's closest and farthest point from Jupiter is only a few thousand kilometers, a rounding error at cosmic scale, but it is enough that Jupiter's gravitational grip on the moon physically breathes. The moon flexes. The tidal distortion of Europa's solid body rises and falls by as much as 30 meters with each 3.5-day orbit. Imagine the ground beneath your feet rising and falling by 10 stories every 3.5 days, without interruption, forever. That flexing generates heat. The same process that makes the ice crack and churn also warms the seafloor. And where there is heat and water and the mineral-rich chemistry of a rocky seafloor being constantly worked by tidal energy, we have on Earth consistently found one thing: life. On Earth's own ocean floors, kilometers below the surface, in total darkness, under crushing pressure, at hydrothermal vent systems like the ones at the Mid-Atlantic Ridge, ecosystems exist that owe nothing to sunlight. They metabolize hydrogen sulfide. They thrive in water above 400 degrees Celsius. They were not discovered until 1977. Before that, the scientific consensus was that life below the photic zone, the zone where sunlight penetrates, was impossible. The consensus was wrong. But here is the part that nobody talks about: the radiation. Europa does not orbit Jupiter alone. It sits inside the most powerful radiation belt in the solar system, generated by Jupiter's magnetic field, which is 20,000 times stronger than Earth's. Every second, Jupiter's magnetosphere bombards Europa's surface with high-energy electrons, protons, and sulfur ions with such ferocity that the ice itself is chemically transformed. The dose rate on Europa's surface is approximately 5,400 millisieverts per day. To understand what that number means, 1,000 millisieverts in a short exposure is sufficient to cause acute radiation syndrome in a human. 10,000 millisieverts is a fatal dose. On Europa's surface, you would receive your lethal dose in less than 48 hours. Not through any dramatic failure of equipment, not through any accident, simply by standing there. Any probe we land on Europa, any instrument we place on that surface, begins degrading the moment it arrives. Electronics fail, sensors drift. The chemistry of the surface material itself is being constantly altered by the radiation. The very ice we want to sample is not passive. It is being continuously bombarded, oxidized, churned into a complex soup of peroxides, sulfur compounds, and organic molecules that are created and destroyed faster than we can measure them. But here is the deeper horror of the radiation. It may be the thing that makes life possible. The oxidants created by Jupiter's radiation bombarding the surface ice, hydrogen peroxide, molecular oxygen, sulfate compounds, could theoretically be delivered to the ocean below through the ice cycling process. The ocean, isolated from sunlight, would have no internal source of oxidants without this. The radiation that would kill any explorer on the surface may be the metabolic engine that drives life in the dark water beneath it. Jupiter is simultaneously the most dangerous thing about Europa, and possibly the reason anything lives there at all. And then the data came back. Between 2012 and 2016, the Hubble Space Telescope observed what appeared to be water vapor plumes erupting from Europa's southern polar region. Not once, multiple times. The plumes reached heights of 200 kilometers above the surface before falling back. The Galileo data, reanalyzed in 2018 by a team at the University of Michigan led by Xianzhe Jia, showed that when the spacecraft made a close flyby in December 1997, its instruments had recorded a magnetic field anomaly and a plasma density spike consistent with a plume impact. The spacecraft had flown through a plume from Europa's ocean, and no one had realized it for 20 years. We have already sampled Europa's ocean. The data exists. It is sitting in an archive, and it has not yet been fully interpreted. The Europa Clipper spacecraft, launched in October 2024, is currently en route to conduct 49 close flybys of Europa beginning in 2030. It carries a mass spectrometer capable of detecting organic molecules, amino acids, and biosignatures if the plume activity is still occurring when it arrives. The mission cost is approximately $5.2 billion. No one involved in that mission will tell you they expect to find nothing. This is where the science stops making sense. In 2011, researchers Brittany Schmidt at the University of Texas, published a paper in Nature describing a mechanism by which surface material could be exchanged with the deep ocean through a process involving shallow subsurface melt pockets, essentially lenses of liquid water forming just beneath the ice, connecting the radiation-processed surface chemistry to the ocean below. This was the theoretical pipeline. Surface oxidants cycling downward to feed whatever metabolic processes might exist beneath. But in running the models forward, the team encountered something they published with careful scientific restraint. The same process that could transport chemistry downward could also, under the right conditions, transport material upward. If there is life in Europa's ocean, it is not necessarily contained there. The exchange is not one-directional. And Europa's surface ice, the chaos terrain, the ridges, the refrozen plates, is not inert material. It is, in the most literal sense, the compressed and refrozen output of an ocean we have never seen. What we are looking at when we look at Europa is the outside of something alive, or something that was. Here is the thing about extreme darkness, extreme pressure, and geological timescales. Life on Earth appeared within the first 500 million years of the planet's existence. Europa's ocean has been liquid for potentially 4 billion years, the same amount of time that produced every living thing on this planet, from the first archaeal cell to you. 4 billion years, in the dark, with chemistry, with heat, with no predators, with no extinctions caused by asteroid impacts, because the ocean is shielded by 30 kilometers of ice. We have been searching for intelligent life in the cosmos for 60 years, pointing our radio telescopes outward, into the vast galactic distances, listening for signals from civilizations around other stars. We have heard nothing. The silence has a name, the Fermi paradox. And the silence has many proposed solutions, most of them deeply uncomfortable. One of the solutions is this: life is not rare, but it is almost always trapped, locked beneath ice on moons of gas giants, unable to reach the surface, unable to reach space, unable to send signals, unable to be found by anything that searches from the outside. The universe may be teeming with oceans. Sealed oceans, on sealed moons, around sealed worlds, in the dark. The question that Europa forces on us is not whether life exists elsewhere. The question is, what kind of life? What does 4 billion years of isolated evolution produce? in an environment with no light, no seasons, no stars, no concept of sky. What is the morphology of something that has never needed eyes? What is the intelligence, if intelligence there is, of something that has never needed to look up? And then, if we find it, what do? We have no protocol. We have guidelines proposed by the Committee on Space Research, amended and re-amended and never ratified into anything with legal force. We have a Planetary Protection Office at NASA that rates missions on a scale of 1 to 5 for contamination risk. Europa Clipper is Category 3. Category 5 is reserved for missions that return samples from worlds with the potential for life. There is no Category 6. There is no framework for what happens if the sample returns something that is already looking back. We built a spacecraft capable of surviving Jupiter's radiation long enough to tell us what is in that water. We gave it instruments sensitive enough to detect a single amino acid in a vapor plume from 25 kilometers away. We aimed it at a moon that has been sitting in our solar system for 4 billion years, and we named the mission after a woman who could not have imagined any of this. Europa, daughter of the Phoenician king Agenor, carried across the sea by a god in the form of a white bull. There is something almost unbearable about that image. The myth is about a crossing, about being carried into the unknown by a force that does not explain itself. We are the probe now, and we are headed towards something that has had 4 billion years to become whatever it was going to become, in the dark, beneath the ice, in the deepest ocean in the solar system, orbiting the largest planet in our neighborhood, bombarded by the most powerful radiation belt we know of, unmapped, unnamed, unsampled, and waiting. Not waiting for us specifically. It does not know we exist. But it has been there the whole time we were looking at the stars. We thought we were alone. We thought the silence meant emptiness. We built our radio telescopes and aimed them at the galaxy and searched for a century. The answer may have been 11 light minutes away, and if it is, the silence was never silence at all. It was the sound of something breathing, very slowly, very deeply, beneath 30 kilometers of ice. In a world we had cataloged as boring and filed away and almost forgot to visit.